So we're going to talk about RRM and how it relates to you in your life. And for those of you that don't know who I am, my name is Krone. I have a bunch of certifications and all that other jazz out there. I run my own company doing training, and then I also work alongside Jake at Velspan as a solutions architect. Yeah, we do still do a podcast. It just has been time to do anything has been a little bit limited lately. So first thing I want to do here is I kind of want to clear the air, if we will, about RRM and what we're going to be talking about. This is not a static versus RRM debate. We're not going to be throwing down in a cage fight and seeing who comes out winning or who comes out with the least amount of bruises in this one. Static is not necessarily better, nor is RRM better. What we're going to be talking about here is we're going to try to understand what is the right config for the deployment that you're doing, because that's the one that ultimately is better. You know, we listened to all of us that have talked this week. You know, we've had some interesting topics around. You know, Andrew, I thought it was really interesting about the whole limit your channels for voice, because it's an interesting concept when you think about it, because we really want to have as many channels used as we possibly can. But the downside to that, obviously, is we've got some roaming concerns about there in terms of DFS channels and everything. I think all of us in this industry, you can look back to a few of my other presentations I've given at WLPCs about absolutes in the wireless industry. We need to be open-minded about things. And we also need to be respectful to one another about things. Because we're all going to do things in various deployments that make no sense to somebody else when they walk into your site blindly and look up and say, oh my gosh, there's 1 AP per classroom, right? We don't know necessarily what those requirements were that they needed to meet or how they did the design process and everything. So I want to make sure that as we start this conversation, the first things that we should get across here is that this is not a debate about which one is better. I use both static and I use RRM when it makes sense. That's what I want to start off with here, okay? So what is RRM doing? You know, what is its job? What is it supposed to be doing, and how is it doing it? So most vendor solutions have some sort of algorithm, some sort of magical theoretical equation that they run through. Are you throwing stuff at me already? Good grief, it's not even started yet. So there's some sort of algorithm that's supposed to evaluate something about the RF. Now, when we go on site and we do a survey, what are we evaluating? We're evaluating the beacon frames, because hopefully we're all doing passive surveys. If you've sat ECSEs, that's been stuck into your brain, that passive from a survey perspective. And those RRM algorithms, so those automatic algorithms, what they're trying to do is they're trying to evaluate and figure out how busy is a cell. Is that cell extremely busy, or is it just a little bit busy? And we try to figure out what type of changes do we need to make to hopefully have the network be better, and what's the impact of those changes. Now it's going to try to run through and it's going to say, okay, Jake, if I tell you to change to channel 1 and Peter, I tell you to change to channel 6, what's going to happen to each of you? Are we going to have a positive outcome out of that? Or are we going to have a negative outcome out of that? You know, a lot of people seem to think that RRM's just willy-nilly out there going, okay, here, you're going to go to these ones. But a lot of the algorithms, they take the time to figure out what happens if I change this one to this one to this one to this one. Because as we know in wireless design, if you change one access point, what has to happen? The other access point most likely has to be changed. Another access point most likely has to be changed. It's that snowball effect as it goes down and down your network in there. So this algorithm is going to try to take a look and figure out what's going on, what makes sense, what's going to be the outcome of making this change, and ultimately will that be better or worse? It's like going to the eye doctor. A or B, A or B. We flip back and forth through this and try to figure out, I want to make the least amount of changes possible. That's the other thing that a lot of folks don't understand, is they want to make the least amount of changes as possible when they're going through this. So if we take a look at some of the vendors here and we look at what are they doing. So Cisco, for example, is going to use this thing called the Neighbor Discovery Packet, or Neighbor Discovery Protocol. NDP is what it's shorthanded to. And when a controller comes online, it's going to elect a RF group master. And that master is kind of the dictator in a way. But the dictator is going to take all sorts of information and feedback and choose what to do with it. It can either say, yes, I'm going to listen to you, or no, I'm not going to listen to you, and I'm going to do what I want to anyways, because I'm the leader, I'm the master, I can do that if I want to. So we look through and we try to figure out, how do we build RF neighborhoods? Because obviously I don't want an access point that's on this floor, for example, to necessarily create and issue changes that should have to happen to a floor 2 stories above me. I only want that impact to be right in this one area. You know, I want to try to, again, control how much change I'm inflicting in my system, and I want to limit the scope of where that change is going to happen. So we build those RF neighborhoods at around approximately greater than or equal to 80 dBm to look at to see you're close to me. So you're all close to me, so I'm going to take you into consideration, and I'm going to use you inside of my neighborhood, and this is where we're going to have our changes that happen. And then obviously each different access point has a potentially different subset of neighbors because they're going to see things differently, right? So then we go through and we try to figure out, what is this cost metric? What's going to be the factors that go into my equation? We're going to look at RSSI on the base AP load. We're going to look at things like code channel interference, look at adjacent channel interference. We've got the clean air chips in there, so we're going to actually look at spectrum metrics for when we do our DCA, our dynamic channel assignment. And then we're also going to have a new thing that's introduced in the 2800 and the 3800 series access points, the coverage overlap factor, or COF. So previously we would just look at it and say, what happens if I change this AP to this channel, to this channel, to this channel? How much load is on channel 1? How much load is on channel 6? How much load is on channel 11, et cetera, as we go through? And that was great, but then we started saying, okay, how do we get more intelligent about it? Because we always design for 5 gigahertz, and we know that if 5 gigahertz works, 2.4 is going to work as well. However, 2.4 is going to take a lot more tuning. We're going to need to go through and potentially turn off radios because it's a better performing network, which seems to go against what we would think about. If you disable 2.4 radios and turn up the others, you're going to have a better experience as opposed to keeping them all down and reducing the transmit power. We've already had a few folks this week talk about reducing the transmit power, and it doesn't do as much as you think it's going to do. So the coverage overlap factor from Cisco, what it comes in to do is it says, are any of my access points redundant? Can I mark any of these radios as a redundant radio on the 2.4 side of things and just choose to electively disable that, or switch it into a monitor mode, or switch it into another 5 gigahertz radio for additional coverage and capacity if there's channels allowed for me. So COF is a new way to hopefully provide value into our systems, because none of our customers or our management teams like it when we tell them, yes, let's go buy a $1,200 access point and then let's turn off half of the investment. So realistically, you're only getting $600 worth of your investment back. They don't like that. So the flexible radio assignment allows us a little bit more configuration and tuning that we can do, and it tries to do it automated. I will say one thing is that I recommend running this in a manual mode so that you get the information, but it doesn't make the changes for you, because take that into consideration as to what would it disable, and are there some sort of business use cases that would dictate why this radio doesn't make sense to be the one that turns off, but maybe one of the neighboring APs makes more sense to be turned off instead. Okay? So what we're going to do for this algorithm is we're going to send these NDP packets based on that neighbor packet. So excuse me, the NDP, which is the protocol, is going to be based on those neighbor packets that we send out. And depending on which code version you're at, so we all live and very much so love the different code versions and the complexities that each of them brings with us. But we have to look at and figure out, okay, which code version are we running to understand how often we're going to send these. You know, we obviously don't want to flood our network with this, because what's our goal of our networks is to get rid of all these management and control and overhead frames so we have all the time to actually do our data frames. Well, in this case, if you're looking at greater than 8.x code, you're going to be sending an NDP roughly every 180 seconds. So when you look at that, if you've got 21 channels, it's going to be roughly about every 9 seconds, we're going to send 1 NDP per channel. That's not really all that much overhead that we're introducing into the system just to run this protocol. It's enough that it makes sense for us to be able to have this view of the network and figure out what's going on from an algorithm standpoint. Now, these are going to be sent at the highest allowed channel power and the lowest supported data rate. Why would we want to send them at the highest allowed channel power and the lowest supported data rate? We want these things to be seen as far as they possibly can, because again, remember, that ripple effect, that snowball effect. If I make one change here, what happens somewhere else? We get another change that's going to have to happen. So we want to ensure that as many other radios in our infrastructure, in our design, can hear these NDPs, because we want tons of data back. We want to get all of that information back to us so that now we can evaluate and figure out what's going on with this network. What does the RF look like from the perspective of all these other access points? Okay? So then let's take a look at Aruba. What is Aruba doing on it? So Aruba does things slightly different. What we're going to do here now is we're going to create a couple different indices, one for each of the channels that we're looking at here. It's going to be what they call their values are an interference index. And it's a sum of SNRs, a sum of signal to noise ratios. And we take that and we relate it to what the coverage index is, which is just our overlap. Kind of how they mark things as, is this radio potentially redundant or not, but they don't have the concept of marking it as redundant. And then we compare those to some ideals, which at least thankfully are configurable, so that you can specify what you want those quote unquote ideals to be for your network, because every network could potentially be different. You know, all of our designs differ ever so slightly. So we're going to take and we're going to compare those values that we got from our indices, look at what the ideals look like, and then we're going to evaluate and do an assigning on it. One of the things that we try to do though is to, again, reduce the amount of changes that we're going to have. We go through and we try to put in this back off on there so that you don't flap. I don't want to have Keith move to channel 6 and then 10 seconds later say, Keith, you know what? That was a bad life choice. Let's talk. You should go to channel 1. And then come back again here and say, you know what? I'm really sorry to do this, but go back to channel 6. Because obviously that's going to have a huge impact on our clients, especially if you're trying to do voice on them, right? They're going to have a huge impact on the clients if that channel keeps flapping back and forth. You know, we hope that our clients will be able to quickly find where the access point moved to, but that's not necessarily always the case. So we go through this back off to try to reduce that flapping, and then we try to figure out, okay, we're going to pull the access points for some more information to see how is the network actually performing now that I made that change. Look for retries, look for low speed frames, figure out are there any fragmentation that's going on, file errors, MAC errors, etc. We look at all this information to see, did this change make it for the better or did it make it for the worse? And hopefully that we have a positive experience out of it and the clients are performing better out of it. If not, we're starting back at the beginning there where we start reevaluating what our indices are, start evaluating again based on off our baseline or off our ideals, and then we change and pull the stats again. Okay. So looking at somebody like Ruckus now. Now Ruckus has what their solution is called, it's called Channel Fly. It's kind of an interesting piece of technology. And one of the intriguing things about what Ruckus says is you should use maximum transmit power. And that goes against what pretty much every single design class or design book or design white paper or anything that has the word design in it has ever told you to do. You know, we've had that whole you should match your transmit power to you should at least not exceed your transmit power by too much. It's changed quite a few often, but we've never at least ever said maximum transmit power. Well, maybe back in like 1999 to 2004-ish or so we were saying maximum transmit power because it was the whole spray and pray scenarios and just throw it out there and see what happens. Well, it's kind of an interesting thing is that based off of how their antennas work, and Ruckus makes some really amazing antennas hooked up to their access points. That's kind of what they're known for is the antenna technology that they put into that smart array, that beam flex antenna array, how it uses basically little tiny semi-directional antennas to create that omni array and be able to say, okay, where is that signal coming from? It's kind of one of the reasons why they look at it from the maximum transmit power. We want to be able to just hear everything and see all that. So we're going to use some background scanning on our channels to figure out what all the different channels look like. Go off channel, see what they look like. Go back, search some data, go off channel, see what they look like, and go through it. So we're going to use real-time stats within Channel Fly to figure out how can we determine, again, what that cell looks like. How busy that cell is, how underutilized that cell is to make some changes to it. This is a positive because if we're using those real-time stats, we have lots of good information about what the cells look like. The downside is that it's going to take longer to settle down because you have to evaluate that cell over a period of time to figure out what is the performance of that cell. Okay, we're good. We're not going to move. Lock. Go back to the next one. Are we still good? Okay, we're not. So then I need to change the channel. Well, now I need to wait another cycle to go through on this. And with any of the technologies that we're looking at, the big thing that we really truly care about is what is the convergence time? How long is it going to take for my design to converge to what I want it to look like? So, awesome blank slide. Sweet, I'm good at Keynote. No, it's because we got the animation here. I really hate animations and stuff, but sometimes it makes sense because it lets me talk through it. So if we look at the wireless design lifecycle and kind of walk through what it should look like, I say and put the emphasis on the should look like, because we all skip steps. We all do this every now and then. But when we go through and we look at this, what is RRM's job? Is RRM's job to replace this entire workflow right here, or this entire life cycle? We enable RRM in the deployment phase. But that doesn't mean for those of us that are designing things, we don't skip the requirements phase. We don't skip doing the predictive phase. We don't skip necessarily the AP on the stick survey if that's what we like to do. We don't skip all those things and go straight to RRM. So RRM is a tool that we still need to work through this entire life cycle to figure out, will our wireless network work or will it not work? So why does RRM fail? You hear it from so many people in the industry that, can I pick on you for a second, Keith? So Keith, he used to always say to me, he said, I fix RRM installs. I'm like, no, you don't fix RRM installs, Keith. What do?
Static RRM installs.
You replace RRM installs with static channel and static power. And there's not necessarily anything wrong with that, because that's what you've understood, because you've used wireless long before we had the concepts of RRM from most of the vendors or any of their radio resource managements. So RRM has a tendency to fail because it's marketed to us, that whole architecture that we have to sift through on every single one of our customer deployments or our internal deployments. We have to sift through that and tell people, no, this is not a replace for a design. I can't just throw up a bunch of access points and then expect RRM to make the network work. It's not going to work. The maximum and minimum settings on most every vendor's defaults for transmit power is the softest you can go to the loudest you can go. And that rarely ever makes any sense whatsoever. So what we need to figure out is, how do we still do that proper configuration? Because RRM is not replacing you. RRM is an extension of you. And I mean RRM in the vendor's generic sense. It's easier to say RRM instead of radio resource management every time. So it is an extension of you. It is not replacing you. It is making it so that that network has a little bit of you that is left behind at every single customer site, just kind of whispering in the ear, what should you do? Should you change this AP or should you not change this AP? Its job is not to ever replace you. So why do we use the defaults? Well, we shouldn't ever. So if we were to give this design to RM and we just throw out this plan here for an office space and we say these are where our APs want to go, and to be honest, I don't know if this is where these APs want to go because we don't have any of the requirements defined or anything, and I just put dots on a map to get some dots on here. But we come up with a design because it meets our requirements, our wall loss values and everything. We went through and we did that predictive design where we set what our maximum and minimum transmit powers. We went through and did all that legwork to figure it out what it's going to be. So how do we then now make RRM or make those systems work that we're looking at? So we need to somehow have the controller, somehow have the collective hive of the access points figure out, I want you to create a design that match that predictive design. I want you to come up with the same design that I did, because that's the ultimate goal of an RRM algorithm. Make it come up with the design that you came up with. So we still need to figure out, just like everything else in the industries, we need to figure out what our requirements are. We have to go through and do that predictive step of gathering our requirements to make those determinations of how we need to configure our RF profiles. Pretty much every vendor out there now has given us the ability to create RF profiles. Even Meraki's given us RF profile configurations, which I love that we finally have that ability to be able to specify how we want different areas of our buildings. Because what is the design that we want to use for this floor that has conference rooms on it compared to the floors above and below us that have the hotel rooms? They're completely different parameters. It's an entirely different design set. So we want to take and we want to configure those RF profiles and then put those access points, have them, the RF profiles assigned to them, so now we can tell these sets of access points, you guys over there, your maximum transmit power is going to be X. Use Uni 1, Uni 2 channels. You guys over here, you're going to be a little bit louder, and we're going to put you on Uni 3. And that's exactly what you did in your predictive design, right? You went through and you figured out the access points over here are going to have XYZ power settings and channels assigned to it, and the access points over here are going to have XYZ power settings and channels assigned to it. So you want to tell RRM to do the exact same thing. You don't want to have RRM just running wild and making its own choices, because then it's not going to come up with the design that you created. And then we obviously need to survey to see if that's going to work or not. I'm a huge fan of doing AP on the stick surveys in extremely critical environments like hospital environments. You know, it's cost me a lot of money to tell them to drill a hole in the surgical suite room, and if it's in the wrong spot because of the sterilization process, chances are they're not going to move the AP for me. They're just going to say, too bad, make it work, and I may or may not be able to make it work. So I want a survey to make sure to figure out, are these settings that I'm going to apply going to make sense or not? Will this do what I want it to do or not? Because we have to tune RRM. I can't stress this enough. RRM fails because we don't tune it. We assume that the vendors have created defaults that make sense. How many times have you seen a vendor default actually make sense? It's not default because it's the best practice. It's default because I have to configure something when I put it into the code to put it onto the product to ship it into your hands. That's the only reason why it's a default. Whether I default 80 or I default 20 megahertz channel widths, you're going to be changing those. The downside is most people assume that a default means it's the golden best practice configuration item that we should do. But it's not true. We need to go through and do those tunings. You want to create the configuration that comes up with the same design as your predictive algorithm did. Take the time to tune RRM. Set those minimum maximum power levels. Don't let it yell as loud as it can and talk as softly as it can. Put that maximum transfer power to what you did on your predictive design, or maybe one step above what you did from your predictive design, because everybody seems to think that RRM is a failover redundancy as well. It's not. I hate to tell you that, but it's marketed that way as, oh, if that access point fails, we're going to power up, and all of a sudden, magically, you've got more coverage. Nope, not true. Spoiler alert, that's not how it works. It's not how it's supposed to work anyway. We're not supposed to do that. Constrain the channel allocations. Again, make RRM an extension of you. If you would choose to not put channels down on that side of the room because you know somebody else is using those channels and you're trying to be a good RF neighbor, or you just know that there's an interference source down there, so I want to take 157 out of that channel allocation plan, do that. Go through and create those profiles so that you can have that configuration match what it is that you would do. Look at your HD areas versus your non-HD areas. I don't mean that we're in 4K resolution and wireless. Remember, high density areas. But when you're looking at the high density areas, understand that what seems the obvious high density area isn't necessarily the high density area. I love the fact that Keith says we don't care about the wireless and we're not going to put power in here because you're all stuck listening to me whether you like it or not because you don't have good wireless so that you can go and look at Reddit for the entire 30 minutes that I'm running my mouth up here. But in this, now he goes to Reddit. But now this is the type of environment where we would consider this as the high density area, but it's not necessarily the high density anymore. Where's now the new high density area? Out in the foyer area or out on the patio outside, because that's where people are trying to use it, or up on the sky deck, which is the awesome place to sit there, but there's no connectivity out there. So we need to look at what are the actual true high density areas and come up with profiles that make sense in those areas to meet our requirements. Think about your perimeters so that you can be the polite RF neighbor. You know, if you're stuck in a strip mall type area or stuck with shared walls with your neighbors, maybe it's in your best interest to find out who the admin is of that neighboring network and say, hey, can we come up with an agreement where I'll use these 3 channels along this perimeter wall and you use these 3 channels along the perimeter wall? Or how can we share and say, let's both agree to talk down a little bit? You know, one of my cousins, he sent me a message this week and he's like, what can I do to make my wireless better? And he lives in Lower Manhattan. And I basically just said, get a wire. Because his response was, well, can I just add more access points? I'm like, if you add more access points, you're just going to exacerbate the problem and everybody's going to be yelling and talking more. And he's like, well, nobody's on any of the other channels on 2.4. I'm like, yeah, there's a reason behind it. So had a nice little education session with him to help him understand what was going on. But if we can be polite and if we can use profiles, tweak it, it's going to ultimately come up with the design, again, that you want it to do. Now, there's some huge concerns, though, that people have with using RRM, and rightfully so. There's always trade-offs. You know, everything in our life, those of you that sat the boot camp with me the weekend or the deep dive, you heard me say this all the time, is risk versus reward. For everything that I do, there's a risk and there's a reward that ultimately comes out of it. So can RRM impact clients? Yeah, because what's going to happen if RRM says, Jake, go move from channel 44 to channel 36, or from channel 104 down to 36? What's going to happen to poor Jake there as he's trying to send frames? He's going to be looking like John Travolta, just kind of, where am I? What's going on here? Where'd the access point go? So we try to be polite about that a little bit, and a lot of the vendors will use 802.11h, which was that quiet channel announcement, to be able to say, hey, by the way, I'm over here now. If I'm over here now, come find me over here. And again, we don't want to change channels. We want to try to reduce as many times as we change the channel so we have proper convergence on it. Now, Aruba is going to use client aware. Those of you that just on a side note, this is how Aruba does their rolling upgrades, the ability to, during a live event, such as the Aruba Atmosphere keynote, they upgraded all their access points a few years ago in Vegas. There's a Gaylord Opry Center in Nashville. Because I was tweeting on it. I got the heads up before that started, and Peg had told me that this was going to happen, and I basically was like, oh, this is going to be interesting. This was like basically, here, hold my beer and watch this. I'm going to do an upgrade during the keynote. But they use the client aware. They use this ability to announce to clients that, hey, I'm going to go over to this channel. Or, hey, go over here and find this access point now. So we try to be polite as we can to the clients. Interesting thing, if you static versus RRM, clients can't probe on DFS channels. We have to wait and listen for a beacon. So if you do use RRM, make sure that the algorithm is doing what it's supposed to do, which is salt and pepper or mix and match DFS and non-DFS in the same area so that we still at least hear some beacons, because I don't want to get a phone call saying, hey, the Vocera badges are not working, and gee, I wonder why they're not working, because they can't probe into, because I got a huge pool of DFS channels in one spot. So do be careful about that, because yes, there are some impacts to the client devices out there and what could be considered negative impacts on them. So my final thoughts here on RRM. It's not going to work in all environments. I've designed and done work on some of the largest cruise ships in the world, or actually two of the largest cruise ships in the world. We sort of made RRM work in some of those environments, but ended up going back to static. Some of the smaller cruise ships I've done, we've got RRM working without any problems on it. So it just depends on the environment. You know, yes, RRM is not our Lord Savior and is going to be able to replace us ever. We shouldn't ever think that it's going to replace us. We still need to have that brain. We still need to have the education that we're getting by going through the CWP programs or going through the ECSE training to understand this is a proper design. This is what makes sense. We want to then be able to say, can RRM create that network for us as well based off of what we looked at? Static does not necessarily create, it does create that sense of stability, but it's not necessarily true. You know, it was static and it was correct for that day. What happens in 2 hours? What happens when they fire up that machinery that was not running when you were on site, and now you've got electromagnetic interference, EMI, coming off of that, and your plan is completely thrown out of the door. We got to get rid of it. There's always a cost for everything in there that we need to take into consideration. And ultimately, your network should not be changing. This is the key. Your network, whether it's running RRM, Channelfly, ARM, whatever flavor that you're running, it should converge at some point in time where it is stable and it does not change every single day. If you're seeing channel changes every single iteration of your automated algorithm cycles, your network design can't be created because your configurations are not set up in a way that they're going to ever meet the requirements. They're never going to be happy. Convergence is key here. I walk into a lot of Cisco designs that are running on RRM, and you can clearly tell that it was we're going to do a rolling installation of this. Because when you look at how the channel plans and everything have been created, there's a whole lot of APs on channel 1 and channel 36. Because when we bring APs online in Cisco, for example, they all turn up on channel 1 and channel 36. And if an AP is on channel 1 and channel 36, and I see another AP that's on some other channels, I want to do as much as I can to not ask that other access point to change its channels. So we don't want to change all that, so we have issues with convergence where we just basically need to restart DCA, give it a little kick in the rear and say, forget everything that you've known about this network by rebooting the controller or on the command line doing a DCA restart so that it erases all of its historical information about what channels were used where and starts over from the beginning so that we can finally converge. Again, if your network is changing, your configuration is not set up properly and you're never going to meet your requirements. And it's all about testing. You've got to do numerous surveys. You know, it's why we're some of the fittest engineers. We don't sit in data centers. We walk and walk and walk and walk and walk. So we have to test to figure out, is this actually going to work? Test those algorithms. Challenge the vendors. We challenged Meraki for many years to be able to say, what does your RRM look like? How does it work? You know, if you have to get under an NDA with them so that they will actually tell you how that works, you know, open up the hood and figure out what it is, do it. Go through those steps of being able to say, can you explain to me clearly how your RRM algorithm works? Because if the vendor can't explain it to you, you're not ever going to be able to configure it and make it work. Challenge them to provide that information to you so that you can learn how it's going to work and then test it in your labs to see what's going to happen. That's what I have. All right, 3137. Hey, we did it.